Betelgeuse, the massive red supergiant star that humanity has been studying for centuries, the one that we keep saying is about to blow, about to go supernova due to the observed unusual behaviour in recent years. It's all unexplained. Well, up until now, astronomers have just seen the faint star orbiting Betelgeuse. But to find it, they use shorter exposures rather than longer ones. How exactly does that work? Hey Space Cats, I'm Dr. Maggie Lou, and in this week's video, let's talk about Beetle Buddy and the power of speckle imaging. Betelgeuse is a red supergiant star nearing the end of its life. When such a star dies, they typically go supernova, a massive stellar explosion releasing a huge amount of energy. For Betelgeuse, astronomers think that this will happen within the next 1,000 years or so. And when it does happen, it will light up the entire sky, like having another full moon. It will be visible even in the day for many months on end. In recent years, there's been speculation that this could happen any time now, particularly with the Great Dimming event in 2019 and 2020, where Betelgeuse dramatically dimmed, dropping significantly in brightness. Now, this was highly unusual, and at first people thought it meant a supernova was coming. Initially, they thought it would be a massive explosion, but later it turned out to be a huge chunk of Betelgeuse blowing off, which then created a bunch of dust in the atmosphere. Now, another thing was that while Betelgeuse was known to have this primary pulsation period of about 400 days due to it expanding and contracting, in 2024, various independent studies actually discovered that Betelgeuse also had a more extended, roughly 6-year cycle of variability in its motion and brightness. Now, this longer cycle is a common feature in about a third of supergiant stars, but its origin has been debated. Theories include complex internal stellar processes, magnetic activity, or even the effects of stellar rotation. This pattern was best explained if Betelgeuse has a companion, i.e. Betelgeuse is not alone, but instead it lives in a binary system with another star. Some scientists even suggested that this system could be a spectroscopic binary, where the stars are too close to being seen separately, but with their gravitational interaction, you can reveal the shifts in their light. These studies even predicted its likely location and orbital path. However, directly observing this binary system proved incredibly challenging because of how bright Betelgeuse is. If Betelgeuse really does exist in a binary, then its companion star is only estimated to be between 1 and 2 solar masses. So in comparison, Betelgeuse is 16.5 solar masses in size. So Betelgeuse would completely dominate this system. The studies also predict the stellar companion to be at greatest elongation, so furthest away from Betelgeuse, in December 2024, with a separation of tens of milliarc seconds on the sky. So building on these predictions, some astronomers observed Betelgeuse during the Great Dimming event in 2020 and also 3 days after the predicted date of the greatest elongation with a special optical camera allopeaky on the 8.1 meter Gemini North telescope. Now, this is a speckle imaging camera. Speckle imaging is a special technique used to obtain high-resolution images of stars and other celestial objects. And they do this by correcting for the blurring effects of Earth's atmosphere. When starlight passes through Earth's atmosphere, turbulence causes it to shift and blur. This makes stars appear to twinkle, and it limits the resolution of ground-based telescopes. So usually, to detect faint objects, we like to take long exposure times. But instead of taking a single long exposure image, which would completely blur out the extra companion, speckle imaging takes thousands of short exposure images on the order of milliseconds. Now, these freeze the atmospheric distortions, capturing the star as a collection of random bright spots called speckles. And then advanced algorithms can then be used to analyze and combine those speckle images to reconstruct a sharper image, often approaching the diffraction limit of the telescope, i.e. the best possible resolution given a telescope size. Now, this allows for the detection of even the faintest of objects, even if they're really close to bright ones, like in this case here. And so with that, the companion star was finally found exactly where scientists predicted it. Well, this is exactly what they saw in the 2020 observations, and this is what they saw in the 2024 observations. This guy here is what they think is the companion. Originally, it was informally nicknamed Beetle Buddy, but now it has the official name of Sawarha, meaning her bracelet in Arabic, a fitting complement to Betelgeuse, which also derives from Arabic and means the hand of Al-Jawza, the ancient Arabic name of the constellation Orion. Now, I know what you're thinking. Why don't we see anything in the 2020 observations? Well, it's perfectly in agreement with what the scientists expected. The companion was expected to be behind Betelgeuse and unobservable at this time. But it's also worth showing too, because the fact that we don't see a companion here means that any detection in the 2024 observations could not be a background or foreground star. Now, in the 2024 observations, you probably, like me, also notice another smudge in the opposite quadrant of the image. Now, this artifact is a very well-known phenomenon in speckle imaging. The ambiguity is inherent to the autocorrelation analysis that they do when processing this image. But the astronomers also use a far more advanced technique called bispectral analysis that I'm not going to go into here, but they use it to resolve it and determine the true location of the companion, so we can be pretty sure that it's there. But it's also worth noting that it's only a 1.5 sigma significant detection, and in astronomy we generally need 5 sigma for a trustworthy discovery. So that means 1 in 2 million probability that is due to chance. Okay, so now back to Beetle Buddy. Based on the observations, this companion is orbiting just 52 milliarc seconds from Betelgeuse, with an orbital period of 6 years. It is so close that eventually it will be consumed by Betelgeuse within the next 10,000 years. And this interaction could actually influence Betelgeuse's eventual supernova process. Now, this companion is also likely to be a young pre-main sequence F dwarf, meaning that it's a star that is still forming, not yet undergoing steady hydrogen fusion, but it is destined to become a relatively hot white-yellow F-type main sequence star. Remember, oh, be a fine girl, kiss me? O-type stars being the hottest at about 40,000 degrees Celsius, and M-type stars the coolest at about 3,000 degrees Celsius. F-type stars sit right in the middle there at about 7,000 degrees. Both of these stars likely formed together from the same giant molecular cloud, which collapsed to create a binary or multiple star system. Most stars that we know of are in binary or triple systems. However, because Betelgeuse was so much more massive, it raced through its evolutionary stages, while Sawarha is still in its infancy or early youth. Sawarha has an estimated mass of just 1.6 solar mass. You see, mass is the single most important thing determining a star's evolutionary path and its lifespan. Stars born with much larger masses will burn through their nuclear fuel, hydrogen and then helium, at this incredibly rapid rate due to its immense gravity causing higher core temperatures and pressures. Massive stars live fast and die young, whereas stars with smaller masses will burn through their fuel much more slowly. Therefore, they'll live for billions or even trillions of years. Well, except in this case, where Betelgeuse will likely cause the dramatic demise of Sawarha. Anyway, seeing such a close binary system up close is super rare, so this is a massive opportunity for astronomers to study stellar interactions. The next predicted greatest elongation, so the furthest this stellar companion will be from Betelgeuse, is November 26, 2027. So another great opportunity to learn more about this companion star. Well, that's all I have time for this week. Thank you to my YouTube Perks members for supporting this video. If you enjoyed it, please don't forget to leave me a like, share and subscribe.
Hey, space cats, fly with me to the stars. Faster than light, so explore.